Today I will discuss about the friction stir welding. Friction stir welding was invented by Wayne Thomas at TWI, that is the Welding Institute, in 1991. Okay, and it overcomes so many problems that will be connected with the or attached with the conventional joining techniques, and that friction stir welding and also low energy input and also producing very high strength welding joint, and also the weld joint also very good quality joint, and also it will do the weld in wide range of materials at low cost. FW process takes place under the solid state welding process, and also that welding has been done below the melting point of the parent metals. We do the welding below the melting points of the parent metals. Generally, classification of the welding, mainly two types of welding process. One is fusion welding. Heated, applied for carrying out the molten state to that particular parent metal, and here no pressure will be applied, only heat will be applied to get the molten state in the welding zone, and no pressure we have applied in that fusion welding. Another is plastic welding. Okay, here also we apply the heat to the plastic state, and also we apply the pressure also. Okay, and due to providing pressure, sometimes when one part is rotated or one part is moving, the friction, mechanical friction will be occurred between two particular two mating elements, and due to movement of that rotating elements, the mechanical friction will be occurred, and also we apply the pressure to that components also, and due to that friction in that particular zone, heat will be generated, and in that particular part that will be converted into molten state, and due to that thing the welding takes place at that particular joint. Example: friction welding and forge welding. What are the main principle of that friction stir welding? First, here we are taken a cylindrical solder tool, that is the cylindrical solder type tool. Okay, we are taken a cylindrical solder type tool. It is a profile probe. It has a probe, that is the profile probe. One profile probe is there to that particular cylinder tool, and it will rotate it, slowly plunged into that joint and line between two pieces of butted together. Means here two parts we have kept. If we are consider that is the part 1, that is the part 2. Okay, and here one probe is there, and that tool is rotated. When that probe going to that particular joining faces or to the particular welding spaces, when it is rotated, and due to that rotation, friction will be occurred between on the contact surface, and due to friction, mechanical friction, heat will be generated, and in that particular zone that will be converted into molten state, very less amount of molten state, and it will help to join that two plates. Okay, and here we are seeing that is the retarding side, and that is the advanced side of the weld. Actually, that part is the advanced side of the weld. Okay, and here also we are seeing that is the retarding side, and that is the leading edge. Means here in that particular direction welding takes place. Means forward direction is the leading edge of that particular probe, and that is the trailing edge. Means that is the end part of that particular tool. That is the trailing edge of the rotating tool, and that across this surface we are doing the joint, that is the joining surface. Okay, and that is the solder tool. So when we apply the sufficient pressure to that particular cylindrical type tool, and due to pressure and due to rotation, the mechanical friction will be takes place between that welding face and the probe face of that particular tool. Now, the heat without reaching the melting point allow the traversing of the tool along the weld line. Means here heat generated, less amount of heat generated, that is the below the melting point. When it will take the friction between that plate, means if we are considering that is the welding phase and that is the probe of that tool, so what happens means when it is rotated and we apply pressure also on that particular tool. So less amount of heat will be generated in that particular mating surface, and due to generation of the heat, what happens now, some part between that contacting surface, some part will be melted, some parts, very less amount of molten metal will be generated, and it will help to connect or help to attach both the metal plate. Okay, and the plasticized material is transfer front edge of the tool, means in that figure we are seeing that is the leading edge, means that is the front edge of the rotating tool, and that is the trailing edge, means in that side it will acquiring the advancing side of that particular weld, and that is the retarding side. That is the retracting of that weld. That zone shows the retracting side of that particular weld. And we are seeing that transfer to the front edge of that tool to back edge of the tool probe, and it's forced by the intimate contact of the tool shoulder and pin profile. Means the friction takes place at the pin, means probe surface and the welding surface, and due to that things of that particular contact surface, the heat will be generated due to mechanical friction, and plastic state will be formed in that particular connecting surfaces, particular attached surfaces, that helps to join both the plate. Now, welding steel using the FSW, friction stir welding, we are seeing in that particular figure, that is both the plate, stainless steel plate. Okay, and here probe is there, and across the joining faces of that particular stainless steel plates, the probe here, that is the probe of that particular rotating tool. If we are kept that particular probe across the joining surface, across the weld surface, when it is going to that particular across the joining surface, the plastic state will be formed due to mechanical friction between metal plate, means welding faces, and between probe. Okay, and due to that thing, the welding takes place across this. If that is the welding space, that type of welding takes place across the zone. That is the welding surface. Okay, means between the contact surface of the probe and welding faces, in that particular faces, what happens now? Heat will be generated due to mechanical friction. Important welding zones in that of friction welding, that is very important. In case of friction stir welding, in its cross section, generally it has three main zones. Okay, first is nugget zone, or it is called stir zone. Another is thermomechanically affected zone, and another is heat affected zone, and another D, that is the unaffected zone. Okay, means base material zone, means unaffected zone. That three zone, the different mechanical properties are shown in that particular zone. Distinct mechanical properties, and nugget being weakest part of that joint, means different mechanical properties you have shown that particular joints, and the most weakest part is the thermomechanically affected zone, and nugget zone, means that is the molten metal zone. That's why that is the weakest part of that particular welding zone. In that figure, we are seeing that A, that is the unaffected material, that is the unaffected material A. Another B, heat affected zone, that is the heat affected zone. That are the heat affected zone. That are the heat affected zone. B zone. Zone B, heat affected zone. A, unaffected zone. That is the heat affected zone. here that is the heat affected zone. C, thermomechanically affected zone. So zone C, that you will see the thermomechanically affected zone. That zone is the thermomechanically affected zone. Zone C, that is the thermomechanically affected zone. And D, that is the stir zone, weld nugget part. Means that is the stir zone. Means that is the molten state zone. Okay. And in that particular zone C and zone D, that is the weakest part of that particular welding zone. That is called, zone D is called weld nugget. Means in that part molten state will be formed, and that molten state helps to join both the plate. And here we see that microstructural analysis. In that cases we have seen that both A, B, C shown the stir nugget zone. Both A, B, C, both zone are shown the stir nugget zone. That is the stir nugget zone, weld nugget zone. And A shows the, that is the microstructural analysis A. B, in that particular zone shows the microstructural analysis of that particular B zone. Okay. And zone C shows the microstructural analysis of that particular C zone. Means that is the weld nugget zone, means plasticized state, means molten state of that particular weld faces. Okay. And here we are see that that zone are the thermomechanically affected zone, and that is the heat affected zone. Okay. Means that part also, that is higher molten state, that is the less amount of molten state, plasticized state of that particular weld faces than stir nugget zone. Another less heat affected zone, means that is the less amount of molten state has been present in that particular zone, and that is the base material. Means here no heat affected zone, no thermomechanically affected zone not present in that particular zone. Okay. Some defects, means due to welding, sometimes some particles accumulated on that particular weld surface. Means that type of problem is called spatter effect of that particular welding cases. Okay. So that is the some microstructure analysis of that particular weld zone. Now as joint geometry, some example, that is maybe that joint maybe has been done maybe horizontally, maybe vertically, maybe overhead position, or maybe orbital, means curved shape positions also. That is the some particular joints done by the friction stir welding. Very good welding quality, very good welding quality. Some joint structures that has been done by the friction stir welding. Which material, particular for which material we have done the welding using that welding process, means friction stir welding. What are the materials? First we have done using that welding process, using in case of copper its alloy, lead material, another titanium alloy, another magnesium alloy, zinc, plastics, mild steel, stainless steel, nickel alloy. For most of the alloy and metals, in that cases we have used that particular friction stir welding process. What are the tool parameters? First of all, H3 steel tools are used. H3 tool steels means that type of tools are we have used. Means in that particular tools, the probe will be connected. Particular probe will be connected in that particular tools, and that probe will be rotated across the welding zone, and it will attach to the welding faces. Means it will rotate it, and again mechanical friction will be occurred between two contact surfaces. Okay, and molten state will be generated, and it will help to weld in that particular welding zone. So that tool must be strong and rigid, because when it will apply the pressure, so it will tolerate the higher pressure, otherwise it will be deformed. So tool must be strong and tough or harder, otherwise it will not sustain the pressure when we apply the pressure during welding time. Okay, have a good oxidation resistance, means that particular tool must be required resistance means corrosion resistance capability. Otherwise, it will react with the oxygen, and due to reaction with the oxygen, the oxide will be formed in that particular surface, outer surface of that particular tool. And thermal conductivity, because when it will that probe will be contact with that welding spaces, means it will rotate it and mechanical friction will be occurred, and due to mechanical friction that steel nugget zone will be formed, meaning plasticized state will be formed, and in that cases more heat will be generated. So that metal must be good thermal conductivity, okay, means heat will be released easily in that through that particular tool also. Some examples we have taken, common tools we have taken, that type of adjustable pin tool also, adjustable pin is there. Using that knob we adjust the pins as per our requirement, and that self retracting pin tool, that type of self retracting pin tool also we have taken. Sometimes pin will be fully fixed, means it does not retracting or does not change, okay, fully fixed, that type of pin tool. Another retractable pin tool and a removal type, that type of tool also we have used in that welding process. Here also we have seen that in case of the stress strain graph, means where we apply the pressure on that particular welding spaces, means some pressure will be applied, and due to that thing sometimes stress also generated, and also some parts will be elongated, okay. So on that basis we have a card, we have drawn some stress strain graph, okay, that is along the x-axis, that is the strain line, and along the y-axis, that is the stress line, okay. In case of base material, we have seen that that is the base material, okay, that is the base material graph, means change of stress strain. In case of base material, we are seeing that the strain rate, means strain rate increases, stress rate increases very less amount, okay, very less amount stress will be increases, but strain continuously increasing, strain rate continuously increasing, but stress increases very less amount. After certain time it will again decreases. In case of friction stir weld, we have seen that the strain increases, strain continuously increases, and certain amount from we are considering from that particular origin, the stress also increases very linearly. Stress will be increased, very higher amount of stress will be increases initially, then after certain time the stress will be increases very slowly, but strains also, in here we are seeing that strain is constant near about, but stress increases very suddenly, stress increases. After that the increase in stress that will reduces here, but it is increases very less amount increases, but here strain continuously increases. In case of base material, again I am telling, the base material suddenly stress increases linearly, okay. After certain time the stress increases very less amount, and from that particular point the strain rate also increases, okay, and after certain time the stress also decreases very less amount, stress amount also decreases. In case of what are the comparisons with respect to other welding process, means the good mechanical properties and good weld quality we have got by the friction stir welding, okay, and that welding has been done below the melting point of that particular workpiece. Also we reduce the distortion, means any type of distortion, any type of crack, that does not happen in that welding process, okay. Reduce defect rate, also we reduce the defect rate also. Any type of welding defect does not generally happen in that welding process. Parent metal chemistry, means in that cases parent metal chemistry also constantly remaining in that particular welding cases also. Simplified dissimilar alloy welding, means in that cases also we are seeing that the dissimilar metals also we have welded using that welding process also. Another eliminates consumables, means here we do not use any extra consumable filler rod. Filler rod means extra consumable filler rod we have not used. Another, reduced health hazard, means in that type of welding process no health hazard is there, no weld pool is there, means that type of things will remove in that welding process. What are the advantages? Very good mechanical properties we have got in that particular welding process. Also, we improved safety due to absence of toxic fumes, means in that welding process no toxic fumes will be generated in that welding process. So it maintained the some safety precautions in that welding process. Another, no consumable, means no extra consumable electrode, no filler rod we have used in that welding process also. Easily automated, means that is the easily automated process on simple milling machines, means some simple milling machines the welding has been done automatically. And that type of welding process also used in all type of positions, may be used in vertical position, may be horizontal position, may be orbital positions, may be overhead positions, we have used that welding process also. Means that welding process has less environmental effect zone, means no toxic fumes, but no another type of health hazards, that type of things does not happen in that welding process. So that is the low environmental impact also. Another, high superior weld strength, means in that weld process the quality of the weld very good, okay, and maintain the higher mechanical strength also in the particular welding joint. What are the disadvantages? Here, workpiece, means where we want to join to both the metal plates, that clamping of that metal plates must be rigid and strong, okay, first one. And here welding rate, means slower traverse rate than fusion welding, means here welding rate is less than fusion welding. In case of fusion welding we do the create the molten state at that particular welding and it will done very easily, okay, but here traverse rates, means welding speed is less than fusion welding. Industry we have used that particular friction stir welding. First one, we use the aerospace applications, that is the one large industry in India. In that particular sector we have used the friction stir welding. Another, ship buildings, offshore, in that cases automobile, fabrication, railway, means very heavy industry we have used that friction stir welding, means it has produced very good welding quality and also it has low impact strength and low environmental impact and also low health hazard. So that's why we are using that welding process in heavy industry in India and also throughout the world. Friction stir welding, here we have seen that is the clamping device, and in that clamping device using pin we have hold that particular metal plate properly, and that is the retracted tool. Here in that tool we have seen that in that particular tool, that is the tool CNC FSW, friction stir welding machines, and in that particular tool we have used the probe, means that is made of the stainless steel, and that is the jig and that is the base plate, and that is the jig. Using that jig we hold the aluminium plate in that particular jig system, jig devices. Now that FSW machine is rotated, and in that is the particular probe, and we apply the pressure on that particular tool, and due to that thing the molten state has been generated in that particular probe and in that particular perimeter across the welding surface, and due to that thing then continuous welding has been done across that welding faces and both the metal plate has been joined. Very good quality welding faces has been generated in that welding process. Then again after welding we remove that all the clamping devices. Finally we have taken that particular plate.